Okay, so just going to go through a polarization index test using the HT Instruments Neptune and the winding simulator that I built up. To set the instrument up, reposition it just for a moment and zoom in so you can see the screen because it's a little bit tiny. There we go, we'll put the light on as well. There we go. So when you switch the instrument on, it stays in auto for insulation tests. We're in the mega ohm function there, and I've set the voltage to 500 volts. That's set using the orange button on the left here. Change between 1000 volts there, 50, 100, 250, and finally 500, which is the test voltage I will use. To get it out of auto mode, I'm going to hit the first button once, and you hit timer mode. There you have 10 minute, 15 seconds, 30, 1 minute, 5 minutes, or 10 minutes. Second press of the mode button, that takes me into polarization index up there, and then I've got a 10 minute here, or I've got a 1 minute function there. So 1 minute being DAR, but it doesn't give you a DAR emblem on there, it just stays as PI. So we'll turn him to 10, and we'll put him back there, we'll zoom back out, and we hit the go button. And it will start its countdown. So you do get a timer here as well, which is nice, and a constant beep, which isn't so nice. So it's finished the PI test, but as you saw, it's one of those instruments that immediately switches over and detects a voltage present, which is because of the capacitive nature of this simulator I've got. So I just removed one of the probes to get rid of that temporarily, and you can see I'm on 32.9 mega ohms as the end result. I can use these keys here, some page through the values, so it was 513 volts. So you don't get the voltage displayed during the test, but you do get it after it. And pi was 7.74 again, and then you get the DAR 1.62. So very nice that you get the two figures. And then back to the insulation value at 10 minutes again. Okay, so that's the test there. Okay, so that's just finished off the second polarization index test on the larger Pi simulator there. That one is 1 minute resistance was 83.3 mega ohms, and on the instrument it read 83.1, so pretty good there. The DAR should be 1.56, and the instrument gave 1.57, as you can see there. And the polarization index should be 5.71, which you can see it's 5.96, so we're a little bit out there. The final reading was 495 mega ohms on the instrument. It's usually around about 470 mega ohms. On the winding simulator, I've got over here that you see tested first, that works out pretty much smack on actually. DAR was 1.62, which is as per normal, and 7.74, so that one's pretty good. So on low mega ohms readings it seems to be a little bit more accurate than on these higher values. Okay, so we've done polarization index tests. We'll move to the winding resistance test now. That will be using the low ohm function on the screen here. Turn the light on as well. As with the insulation testing, you've got some options when doing this test. You have the limiting function here, so you can set whatever value you want this to be to. It seems you can hold the button in as well for fast settings, but it is a bit finicky to do it overall. It doesn't appear to be a way to move it and do separate digits. You have to just keep winding it in this manner here. So yeah, not the best way of setting that. but that's that one. With regards to the test mode, you've got the auto function on here. I don't know whether you can see that. That's really bad on the light. Just zoom in for a moment. There we go. You've got the little auto function up there on the screen. You can change that to a timer function, and you can set the timer here. I'll put on screen what the actual maximum is so you can set it to. So that's that bit done. Zoom back out again. Try and get you up the screen. Okay, so we'll use our winding simulator again. Oh, first of all, we've got to we need to zero it. So this has a zeroing function as well. So I'll click the leads together and hold the 0, and it goes through a little cal. 0.08, it's not bad. Interesting. Didn't zero that out completely, did it? 0.09, 0.01. Okay. Got the total 0. We'll see what readings we get with regard to this. So we'll actually flick him to auto. So in delta we've got 6.76, and I'm pretty sure that's too high. 6.79, and the final one 6.16, reasonably consistent, but that's way too high. What are we in delta? So in delta it should actually be 1.17 ohms. But we've got the test current there as 209 milliamps. Let's just flicking around. We've also got the normal ohms scale here as well. There you see 1.7, 1.8 ohms, 0.6. So still a little bit high, but at the end of the world. I do sometimes see this. So 0.3. Let's see if we can. Yep, we've got 0 on that as well. Go again. .3, too bad. 1.2 is about there, isn't it? 1.2 again. Okay, so it works better on the ohms than it does on the high current ohms. Okay, let's just. Sometimes I do have issues with these instruments with the high current because that's actually an inductance in there, not straight resistance. This box here is straight resistance, which is 96.5 ohms, and we're reading 99, 99.8 ohms on the other one. And we'll flip him around to low ohms. It's retained its 0 anyway, so we'll just do that one. 99.9, test current's naturally dropped to 77 milliamps, so that's fine. So yeah, pure resistance, it seems quite happy. With some inductance in there, the 200 milliamp range appears to be struggling. What I'll do is I'll just drop off the links off of the winding simulator, and we'll put him into so this will be actual open winding configuration, and we're looking at 1.75, 9.06. Okay, that's not good at all. 9.34. 8.76. Must be miles out, isn't it? But, drop them into star. So in star format. So star format, I should have 3.5 ohms or 15.4. It's going up. Wow. Don't know what to say about that. 15.6. So it's consistent, reasonably consistent in there, but that's nowhere near the value it should be. Just to prove the point, I'll slide him out of the way. I'll use the same leads and switch him on to auto mode. Oops. Can you say it's in the screen there? 3.59 ohms there, which it should be 3.5. And let's put that up in there against the 14.9. So we've got 205 milliamps on there. 205 milliamps on that. That's interesting. 205 milliamps test current on both of them, but this one reads correct. Something wrong with the Neptune there. Not sure. As I say, I do sometimes hit issues with 200 milliamp test currents on these instruments that have a lot of inductance in them. So what I need to do really is take this little Neptune out and measure some actual motors with it and see what that brings. Okay, so another slight anomaly we've got with the HT Neptune. We've got our insulation calibrator. We're on open circuit volts test. I'll set them to 50 volts and I'll just zoom into the screen so hopefully you can see them better. So hopefully that's set up. So we're on open circuit voltage test, we're on 50 volts. I'll hit the button. We can see we've got 52 volts there on that one. The tolerance for the test is 0% up to plus 10% for this particular instrument. We'll go up to 100 volts. Hit the go button again. Again, we see we're above 102 volts there. If I page back through, you can see we're 105 volts on the machine, 102 volts on the calibrator. So 250 volts. We've got 246 volts there now. And if I go to, it says 259 against the 246 volts. 250 volts, which the meter says it's okay, but the calibrator is saying it's wrong. 500 volts, we'll do the same again. 479 volts, but when I go 512 volts on the instrument, you can see that. And finally we got to 1000 volts. You've got just over 1000 volts there, so that's fine. And 1049 gigaohms, so it's about 1 gigaohm loading when I do this test. Voltage wise, we're 1030. So the calibrator seems to be reading low and actually fails the instrument on the 250 and 500 volt tests. Just to show, calibrator is okay. 264 it's saying down at the bottom there, 263 volts on the calibrator, so that's fine. Go up a range, go again, 525 volts on the instrument and 523 volts on the calibrator. So the calibrator seems fine and it seems like there's an issue on the voltage. So based on this you'd probably kind of think there's an issue with the instrument on the 250 volt and 500 volt output, but we've wired this direct to the fluke now. Fluke's set to voltage DC. We're in 250 volt mode, and if I hit the go button, you see 258 volts reading on the fluke, and 258 volts was recorded by the Neptune. Pumping up to 500 volts, and go again. That's 510 volts, and it's 510 volts on the Neptune. So there seems to be some sort of an issue with this particular instrument with reading the open circuit voltage on the calibrator. And that is not actually everything, so we'll just reset out again. Just plug my Neptune back in to the calibrator. So we'll go to 50 volt mode. This time I'm going to turn it to short circuit current. and we'll test again. .4 milliamps there. I don't know whether you heard, I'm going to clip the microphone close to the insulation tester so hopefully you can hear the instrument. So 50 volts. Go up to 100 volts. 250. 500. And finally 1000. So hopefully you heard the different pitches of the resonance in the instrument as you go through the different test voltages. That's at short circuit. At higher resistance values it's fine, you don't hear that resonance. Now if this was a switch mode power supply you'd perhaps be concerned about that because you don't want your HT transformer resonating in that manner, that'll wear it out. With this being an insulation tester, the amount of times it will pick up a short circuit anyway, it's not really that big an issue, but it does point to resonance within the instrument that you don't usually hear. And just to prove that, I'll flip over to the 1587 and I'll test that in the same manner on short circuit current, and you should hear very little coming out of it. Okay, so we're on with the fluke, 50 volts. You can't hear anything. We'll just go to 500. Yeah, nothing can be heard really. And finally 1000. So yeah, you just don't get the same resonance in this fluke that you're hearing on the HT Neptune. It's either that or this has got much better sound insulation around it. But my suspicion is it's more to do with the design of the HT output rather than the actual instrumentation mechanics. Yeah, okay, so there's a few outstanding issues with this HT Neptune I need to do a bit more investigation on. That's pretty much it for this video. Thanks for watching. Hope you found it useful and interesting, and I'll see you again in the next video.